Modbus RTU Maestro is a Windows application designed to emulate a Modbus RTU master and multiple slaves. When you launch the software, the main window allows you to choose between the Modbus master, Modbus slave interfaces, or both. Please note that you need real RS-485 hardware to communicate with external devices, or between the Modbus master and slave interfaces offered by the software. Let's start with the Modbus master interface. To launch it, click on the Modbus master button. To enable communication with slaves, first select your PC's serial RS-485 interface, and adjust the settings. Make sure these settings match those of the slave or slaves you wish to communicate with. To see the results of read operations, launch a watch window. Watch windows display the values of the coils and registers you want to monitor. You have two options for launching a watch window, attached or detached. Attached windows appear on the right side of the Modbus master interface, for an integrated view. Detached windows can be dragged anywhere, even to another screen, for your convenience. Let's start by adding a slave. The slave address should match the address of the slave you are monitoring. Next, add 10 coils to the watch window, starting with coil address 0. Initially, all coil values will be 0 since we haven't communicated with the slave yet. To read the current status of the coils, we need to send a read coils command. Click the Read Coils button on the left side of the Modbus master interface. We'll keep the slave address as it is, since we're communicating with the Modbus slave at address 1. The start address should also remain at 0. You'll notice there are two input boxes for the start address. These boxes are internally linked, allowing you to enter the start address in either decimal or hexadecimal format, which can be useful since device documentation may use either format. Finally, enter 10 in the count box, as we're requesting the values of the 10 coils starting from address 0. Then click the Send button. After sending the request, the slave should respond with the coil values in the appropriate format. You can view the byte values of both the request and the reply in the communication monitor, located in the lower left corner of the interface. If the slave does not respond, a timeout warning will appear instead of the reply bytes. If the slave returns a fault, the fault code and its meaning will be displayed instead of the reply bytes. Please note that only common Modbus RTU faults are displayed as a message. If the software doesn't recognize the returned fault, it will only display the received bytes. If the returned value is a valid Modbus packet, the received values will be shown in the watch window. Coils set to a value of 1 will be indicated with a green dot, while others will remain at 0, with no green dots. Let's try reading the holding register values. First, add the holding registers you want to monitor to the slave watch window under the Holding Registers tab. Then, send the Read Holding Registers command, by clicking the corresponding button. Since we're requesting to read the values of 10 holding registers from slave 1, starting from address 0, simply change the register count to 10 and click the Send button. You'll see the communicated bytes in the communication monitor, and the actual values in the watch window. Let's move on to handling float values. In Modbus RTU, float values are represented as 4-byte numbers spanning 2 registers. Before sending a request, add 2 registers to the Holding Registers tab in the watch window. Then, select both registers by holding down the Control key and clicking on them. After that, click the Mark Selected Register Pairs as Float button. The registers will be marked as float. Next, go to the tab for holding registers reserved for floating point numbers. You will see the registers combined into a single box with the float value displayed. Remember, the number of registers marked as float must be a multiple of 2 since 2 registers are needed to represent a float value. Let's request 2 holding register values from the slave. We need to know the addresses of the float value beforehand. In this example, the float value we are requesting is represented by 2 registers starting from address 0. Click the Read Holding Registers button and increase the number of registers to read to 2. Then click the Send button. If the slave successfully replies, the software will combine the registers into a single float value and display it. Another feature of the software is the queue list. We can queue multiple read-write requests and run them continuously for as long as we want. This is especially useful for testing purposes and for monitoring changes in values over time without having to manually make requests repeatedly. Let's try an example. Start by adding 3 holding registers to the watch window. Then, click the Write Multiple Registers button and add 3 more registers to write values to, assigning different values to each. Click the Add to Queue button to place the request in the queue. When the right request is made, the slave will receive the values and make the changes. However, the watch window will not update unless we read the values back. To do this, make a read multiple registers request for the same registers and add it to the queue. Next, go back to the write multiple registers request window, change the values, and add this request to the queue again. Then, add another read request. This way, we will continuously change the values and monitor the updates in the watch window as a result of the read requests. Hit the Start button and watch the values change over time. This finalizes the Modbus master part of our tutorial. Let's see how the Slave Simulator feature works. Click the Modbus Slave Simulator button on the main window to launch the slave interface. Select the serial interface you want to use and click Connect. Ensure the slave address is correct. Let's start by adding some coils to our slave. Click the Add Coils button and add 10 coils. When the slave receives a write request, it updates the values of the coils, and when it receives a read request, it replies with the coil values. The same applies to the registers. Values can be read from and written to the registers in the Slave Simulator. Thank you for watching our tutorial. We hope you find the application useful.